and we started to modularize it enough so that we could put a price together for it so that we could put a submission in next week and see what happens. And lo and behold, I guess my number must have had a lot less zeros than everyone else because they called us back and they came out, they inspected our facility, and they were looking at me sideways. They really were, right? Well, how are you supposed to do this? So I sat down and I told them. I walked them through the process of what we're going to do and how we're going to build it. And it was enough to alleviate their concerns.
Welcome to Manufacturing Insiders. Today I have Martin Cox with me. Martin has a 30-year history in the manufacturing space. He's founded several companies. He is an engineer, an inventor, just a really passionate guy about manufacturing. And I'm excited to pick his brain today just about the product development process, kind of where he sees manufacturing in the United States headed, and just really how he's been able to, build successful companies in the manufacturing space and build successful inventions and really have a lot of success with them. So welcome to Manufacturing Insiders, Martin.
Thanks very much. Thanks for having me.
You are very welcome. One quick note before I get started. If you listen to this and you enjoy what you hear, please like and subscribe to our channel. Also, if you are a leader in the manufacturing space and you have some interest in sharing knowledge with other leaders, please go to manufacturinginsiders.com, fill out the form there, and we'd love to have you on as a guest. So, Martin, give us a little bit about your background. I believe you came from the UK and were educated there. How'd you end up in the US, and how'd you end up in, kind of that electrical subsector of manufacturing?
I exited the UK in the mid-'80s and ended up in Canada. And at the time that I arrived in Canada, in a place called Vancouver, there wasn't a lot of industry there. So I was trained in electrical electronic engineering, went to Canada and ended up becoming a welder because there was work for a welder to be done. So I worked as a welder, got my certifications of Red Steel Journeyman, welding certification, and then realized that there was a big need in North America for combined services. And by that I mean it's an engineering focus that's not directly just focused on one area, electrical or mechanical, or tooling or civil. It's someone that actually encompasses all of the areas together and designs and builds a product that solves the solution from all areas, rather than just from one little point of view. And that's what started me in business.
Very interesting. So how did that vision for sort of an integrated engineering approach manifest itself, maybe in your first venture?
Well, initially, I was customer work at a fab shop, and we were designing 3 and 5 axis CNC carvers for the prosthetic industry. So we designed the machines that made the actual molds to make the blanks for the legs on. And then we designed thermoformer, which is another type of machine, and then we started dabbling in software by trying to do a cloud-based and loop software to actually scan people's limbs so that we could make the initial manufacturing by the doctors a lot easier and a lot more efficient. And then from that point, we kind of naturally gravitated to industrial. We got asked to do things because we were seen in our areas being the experts in non-ferrous. And non-ferrous is aluminum and stainless steel type products. So we ended up getting tapped to do the RAV line, which was a 19.5 kilometer power system and integrated walkway in Vancouver. And that was probably one of the largest projects that had been released in Vancouver in 10 or 15 years. And we were able to get it. And at the point we got it, I was a 5-man factory, or 5-man, right? And we had 19 kilometers or 19.5 kilometers to provide in a little over a year. And we actually brought it in 7 months ahead of schedule, the main project. And what we did is we did what no one else did, is we modularized everything, right? We designed it in one big solution, and then we modularized it, made like 8 or 10 different parts rather than 19 kilometers of custom pieces, which, weigh a ton. And then we converted the material, so we played with material selection. We looked at lifetime usage and as far as survivability of the product in its usable state. And we converted the materials used. No one has ever really used aluminum series and extrusions on a rail system before. It was quite interesting when we started delving into it that everyone uses steel, hot galvanized steel, bolt it together, they weld it together. It's heavy, it's awkward, it rusts. We came in with, custom design extrusion, so we could put the mass of material where we needed it. So it was strong where we wanted it, and it was light where we wanted it there. And shaved tons and tons and tons of this. And then because we modularized it, we made it easier to build. We can now use robotics. We can now fine tune how we were doing things and actually bring the project in under cost.
Wow.
Yeah.
So I'm interested to hear how you were able to win the bid in the first place. Like, being a five-guy shop, I would assume they'd look at you and be like, I don't think you're gonna be able to do this.
Yeah, they did. They couldn't get past my number. So the interesting thing was I walked into the initial offering. I was invited in as a guest to sit at the back and just see how things work, because two of the biggest steel fab companies in Vancouver were at the meeting. One walked in with 12 guys and one walked with 18 guys, right? So like 17 draftsmen and a BA. And I'm sitting there at the back of the room with this package of drawings that's about 2 inches thick. And I'm listening for all the questions that these people are asking and going, you guys don't have any idea what you're doing either, right? So it's not just me. You've got 19 guys and you've got 12 guys and you haven't got a clue. So then I started looking at the drawings and going, well, these are terrible. These are like it was built in 1945. And, we build things, at humanity, we design a building or we design a part, and we don't change it until someone innovates, right? Because why would you? It's already done, so we're just going to redo it. But we're at the time, in the 80s where materials were starting to increase in price. Availability was starting to get harder. So at the end of the 2-hour meeting and listening to all these people ask these questions, which in my eyes I thought was silly, none of them really got to the point. I asked one of the lead engineers, I said, can I take this package with me and quote it? And he said, sure. So I went back. I think it was Friday afternoon. I had my meeting. I went back. I sat down with one of my engineers in my facility, and we designed a new system over that weekend. So we essentially designed a new type of walkway, and we started to modularize it enough so that we could put a price together for it, so that we could put a submission in next week and see what happened. And lo and behold, I guess my number must have had a lot less zeros than anyone else, because they called us back and they came out and they inspected our facility and they were looking at me sideways. They really were, right? Well, how are you supposed to do this? So I sat down and I told them. I walked them through the process of what we're going to do and how we're going to build it. And it was enough to alleviate their concerns, and they allowed me to, continue to win the award of the system. And then we got involved in other projects on that, where we did the spaceways in the stations and a bunch of other technical stuff too. So it was catapult for Cox Metalworks into the realm of cable bus, cable tray, and electrical type systems.
Yeah, and I would imagine it grew your team. I mean, what did your team look like at the end of the project? Still 5?
At the end of that project, we had 20.
Okay. Well, still, even with 20, these people had more advisors come into the meeting than you're the size of your company. I love that, though. I mean, that just speaks to entrepreneurship, because that's what we do. Is our eyes are bigger than our mouth. We look at things and we say, you know what, I can do that. People are like, you're crazy. My mom has always kind of joked about that, because I've never said no to anything. I'm like, I can figure it out. I'll get it.
Exactly. You'll learn, right? So, yeah. And your chances are you will do a better job because you will have to think about it and figure it out. Whereas another company will copy something that someone else figured out 20 years ago. And it's all technology. And that's part of the problem with our industry today, is we have really old technology and old ways of doing things and new state-of-the-art ways of doing things, which aren't really coming together very well.
Right. So, obviously this was kind of like your big initiation into, just a revolutionary design for things. I would imagine that is carried forward, and that there have been other things. And I know that we are going to talk about the Hollobus.
Yeah.
What other examples, things you've invented, and what have there been instances where you just saw a need and created something new, or is it usually kind of driven from another organization to you? They have a problem that needs to.
Both. Some of the products that we design are ideas of mine that I've had, and then we vet, obviously very well, because everyone is full of ideas, but the question is whether they're actually good ideas. We don't know yet.
Right.
So I look at the marketplace and I look at what's going on, and I look at where I foresee pain points to be. So Cable Bus, our Superior Bus product was designed because the cable bus that was out in the marketplace at the time that we started looked like it was being built in the back of someone's garage. And it really was, to be honest, the way it was being built. And it still is today by certain manufacturers. No one had done any analysis, no one had done any engineering or design into this. They had just taken what the code book said, and okay, we can build it, right? Drill some holes in wood, slap it in some cable tray, put some cables inside it, we're good. We'll call it Cable Bus. Well, that's not the way that product works. So one of the nice things with the Rev line is we made a reasonable amount of money, and we invested back in the company into R&D. And we're a company that does typically 1 to 200 at least minimum a year in R&D. We're always research and developing either improvements in our products, equipment, or new technology. So when I looked at what was going on with, let's say, the Cable Bus product, I was in what probably the same position you would be in, is I knew nothing about it. I'm electrical, so I could do the electrical calcs, but what are the magnetic fields? What are the forces? What are the pain points? Where does it fail? Why does it fail? So I spent basically a 2-year deep dig with a three-man engineering team designing software to analyze what happened inside a confined space with a lot of cables. And when we created that software, we then realized that we had problems in other areas of the product because the product wasn't designed to carry the load and the effects and all the detrimental problems in the event of a short circuit. So we then have to design a new block system and a special guide system to stop the conductors from damage. And then part of that now is where you have to build it, so you have to build it efficiently because you're still competing with someone that's building it in his garage, right? So you have to beat them on technology because you can't beat them on manufacturing costs because, one, I was in Vancouver, probably the most expensive place to do business in the world, upwards of $1,500 a square foot for industrial property. Our wages are very well, our benefit programs are very highly cultured in Canada, I would say. So it's probably, if you're talking about trying to be competitive to anywhere else in the world, it's really hard. You have to do it on technology, right? And that was part of the drive. We had to be better than everyone else. We had to have more automation than everyone else. And I don't mean automation in the factory. I mean automation by taking some parts and having them injection molded or having them blow molded or machined ahead of time so that you could actually just take parts off the shelf together. So there's a lot of engineering design that goes into, again, not just the product, how it works, how it lasts, but how you build it efficiently as well. Because in the electrical industry, the way it typically is that if you're $1 higher than someone else, they won't buy it. It doesn't matter what benefits your product brings to the marketplace. Most don't see it because a contractor may buy it or an OCI may buy it, and they may sell the building year, so they don't really care if it's a 1990 lifespan. They care enough to survive the warranty and get paid.
And also it's heavily regulated, so I think a lot of times, people would see buying a new product, or there's risk associated with that they just don't want to deal with.
Yeah, and it's funny, they will buy an old product that is constantly failing, right, without a problem, knowing it's probably going to fail. Easier than buying a newer product that won't fail.
Right. It's even worse than if it ain't broke, don't fix it.
Well, I think it comes down to any engineer that specs a new product or wants to go a new direction, he carries that load. If that goes wrong, he wears that banner, right, for a period of time. So a lot of engineers are gun shy of changing the way they do things, because if they do it the same way they've always done it and it fails, well, the way we've always done it, right? So it's not my fault. The minute you make a change, you now carry that weight and that liability.
Right. Yeah, and I hear this a lot with different new technologies. I was just talking to a guy who made a way that you retrofit CNC machines with additive manufacturing technology. And one of the things we talked about was the fact that the engineering specs, even though you could use his product to match the specs and to do the same process or even do a better job in some cases, the engineering specs are so rigid a lot of times that you are not able to use this new technology. And so we've been talking about ways to kind of to change the industry from the top down and allow more flexibility in the way things are specified.
Yeah, and for that, engineering training is the only way to go. The engineers need to understand what it is and get behind it. That's the only way, I think, in North America today you're going to really bring in a new product into the marketplace, unless you have billions of dollars behind you and you just go out and do blanket marketing, right?
Right. So what's the mechanism of that training? How could you in mass train the engineers to understand a new technology?
So my job for many years has been just that. I do lunch and learns. I do training seminars. At one point, I actually did a professional development hour credit on the East Coast, where we would go and we would rent a hall and we'd invite all the engineers around, and it would be a morning event, and we would teach them the new technology, the ins, the outs, codes, and requirements for it, and then usually put on a lunch, and then they would get a professional development certificate with that, right? Which all engineers have to continually do professional development, so it's practical for them as well. And what you find is you may not turn every head in the room, but there's usually quite a few that go, okay, we see it, right?
Yeah.
The simplicity of a product sometimes is a detriment when it's done. When you design something very well where it looks easy, there's a potential issue with engineers going on. It's simple. It's not. The engineering, the design that went in to bring a product up to the level we are at now was millions of dollars and years of investment and testing. But the end result is something that is a funny that looks really simple. And some of them understand that, and other ones don't.
Right. Yeah, I mean, certainly that's an interesting angle. So in order to put on this seminar for engineers, I mean, that's money out of your own pocket, and then obviously you have to figure out how you're going to market it to them and get some sort of a critical mass of people there.
Yeah. So in manufacturing today, when you take out all of the massive, the Googles and the massive companies of North America, which they're their own entity. Everyone else is a mom pop shop or slightly bigger, right? 50 employees, 100 employees type thing.
Right.
We're always fighting for work. So it's not easy. It never has been. What we've typically used is manufacturing agents. So there are agencies around the U.S. that actually just have to rep a product or a company in the sales market force. So we work with them in trying to strategize and figure out who the people we need to be taking our product in front of, and then we work with them to figure out how to do it. But ultimately, you're right. It's the manufacturer that typically carries the entire burden of trying to get its product known.
Right.
And trade shows, for me, NICA, the IEEE, Data Center World, and shows like that are very supportive for what I do. But if you have another product, you look for shows that are more supportive for the races that you want to look at.
Right. Yeah. Yeah. I actually fresh off of a trade show. We went down to Chicago for FabTech, and I was very impressed. As a business, I've never really gotten into trade shows too much. We've pretty much relied on our own techniques of digital marketing to get business, but we decided to kind of try something new. And so I went down there with a couple of team members, and I was very impressed. I mean, even not having a booth, just kind of walking the floor, we had, just an incredible amount of interesting conversations. Probably got a good 50 leads for the podcast, and some for the marketing business. So it was pretty neat.
We were in the building right beside you at the same time. So we're at the Neat
okay.
Show. So we had two booths set up there, one for Hollobus and one for Spirit Price. And those shows are, like you said, interesting because you get to meet some very unique individuals, with some very interesting ideas at certain times.
Yeah. Yeah, it was fascinating. The one thing, that strikes me, because I have a lot of conversations about automation on the podcast, because I truly believe that U.S. manufacturers need to embrace automation and do it quickly, if we're going to remain competitive in a global marketplace. And, I was talking to some of the guys at Fanuc and, some of the other robotics companies there. And, I asked them, what advances have really been made in robotics technology? Because it seems to me, and there are people that agree with me on this, that it's still very much traditional machine learning. Obviously you can train a robot to weld a line, flip the part over to weld the other side, etc. But when is there going to be an intersection with AI as we know it? Obviously right now we interact with AI every day. Everybody's using ChatGPT and these models that are generative and that can think outside the box a little bit, things like that. When do you have the robotics technology that can make some decisions on its own?
Well, it's already there. You can get camera mount systems which the robot can think for it. Well, I use the word think. No, it doesn't. It follows a program and a set of routines. But you can actually essentially put a box on a desk, have a pre-programmed robot, and the robot can actually look at that box, see where it's aligned, figure its place, and then rearrange its toolpath, right, to make that work. So we do have that. The problem with that technology and automation in general, it's damned expensive.
Yeah.
It really is. And automation purchased in the U.S. is probably the most costly automation I've seen in my life. I'll give you an example. I purchased a 6 kilowatt CNC fiber laser with swap tables and a pipe cutting attachment on the side to cut up to 20-foot pipes and systems.
Yep.
And when I went out in North America looking for a price, I was, by the time you added up both, close to $700,000. My landing cost using an Asian company was just over 100.
Oh wow!
Right. The technology is really not any different. In fact, when you look at a lot of the stuff that you see advertised in the States, and you go over and look on, an Asian website, you'll see the same picture on there. So the question is whether you can build them yet. The problem I see at this point in manufacturing is outside of the big people, the big players, usually the publicly traded corporations who have the billions of dollars or millions of dollars to put into building a line, and they'll build, a $5 million or $10 million line for one part, right? The rest of us don't build one part; we build multiple parts. So our lines have to be somewhat flexible, right, in our design. It's not as easy as building a radiator cap. You build thousands a day, and every day that's what you do. My robotics in my facility do many, many different things. So sometimes the task is doing project A, sometimes B, sometimes C. And sometimes you can't use them because it's just a little bit outside the scope.
Right.
And then the downside we have also to automation, as much as automation is a fantastic tool, is jobs. We have de-skilled in North America as a whole, we've de-skilled our population. years.
Mm-hmm.
You know, even self-driving cars, as much as they're great, I'm going to call it gimmick, but I don't mean a gimmick, it's not the right word. You know, all that stuff is all great, but now you don't have to drive. So are we going to distill people to the point where they don't know how to drive either?
We're working towards it.
Yeah, you know, I work with electrical and computer engineers that have never built a PC. So when something goes wrong with a PC, they have no idea to check RAM, check this, you know, all the basic stuff that we would do, you know, we learned at a younger age because our technology was at a much lower level than it is today. The problem where it is today is it's getting so technologically advanced that no one can really mess with it, no one can play with it. It's hard to learn.
Right.
And your employee requirements are going to change too. So in a lot of towns in the USA where they've had big factories and big factory jobs that they don't have anymore, they're looking for factory jobs. You know, push a button, pull a lever, put a piece in, do one or two actions. And now what we're trying to facilitate in this country is automated factories that require people with degrees, right? Because you can't put one of those persons with a robot. You need someone that has a tech degree to be able to understand the software. You know, has to have enough training to be able to, you know, manipulate the controls and figure everything out. So we've got a big issue that we're trying to solve ourselves in our new factory in Kentucky, and that's really the blending of automation with work, right? And it's hard, it's very hard. That's why I don't know if you heard last week, but a dark factory has been actually put up in the States now. So they have them in China, factories with no work center. It's all fully automated. We have one here now, which is great for the company that's building it, but not good for the people living around it that don't see any employment from that, right?
Right. Yeah, and I mean, a lot of the robotics integrators that I've talked to, you know, kind of look at it from the perspective of we already have a shrinking workforce, and you know, these companies can't find the employees, so the automation isn't necessarily taking people's jobs; it's replacing, you know, the non-existent employees.
And you're right; it's a snake eating its tail. We're in the same position, and I, you know, there are so many things at play right now in our economy that make business hard, right? That make it hard to find good employees, hard to retain, you know, good employees, and then hard to get the product out the door in a competitive fashion because again, you're always going up against someone else. There's almost no one in this world that is a sole supplier. You know, everyone has competition in some realm of form, which means that you've got to raise your cost. And I don't know where that level of automation is going to stop. Because again, having a fully automated factory inside, you know, a 30,000 person town is great, but it does no good for the town if the people living there can't afford to buy your product.
Right.
I don't have the answer to that, and I'm not claiming to. So.
Well, no, I mean that's the fear with AI in general is, you know, the people that are developing this stuff, you know, Elon Musk's of the world, you know, he predicts that we have a future in which people don't have jobs and that AI and robots are doing literally everything for us. You know, so at that point, you know, what do people do? And
so would that be before or after the revolution that everyone starving comes out with their guns and pitchforks and decides to overthrow authority? You know, and that's it. It's easy to say that we're losing jobs, and we are. We've got, you know, since COVID, I've seen a massive difference in the way industry works. There seems to be a big push to remote work, stay-at-home work, you know, work in the basement, stay with your parents and all the other stuff, which isn't conducive to manufacturing. We can't do that. We have to be in a facility, right? We use large amounts of power, we use big equipment, and you can't do that remotely. You have to do that there, which is troublesome for any manufacturer. But the problem is, and he's right with the automation, is the automation will come in and take semi-skilled jobs. It won't take the dumbed-down jobs because automation won't do that, right? So you're still going to have the low level, pulling a lever, pushing a button, sweeping the floor. Then you're taking out almost all the jobs between them and high-tech technicians.
Right.
What happens if AI ever goes down or automation
Somebody
fails?
smart's got to fix it, yeah.
Well, there aren't anyone, right? There's no one out there. Machines today, unless you build them yourself, which is what we chose to do in this facility, is every single equipment that we bought, we installed ourselves. Mm-hmm. Obviously, some of it's pretty big, comes in multiple containers, and we built it. We took a lot longer to build it. We may have made some mistakes in building it, but we know that it goes down. So when it goes down, we can actually troubleshoot it. Whereas with AI and bringing in modules that are pre-dumped to you from all these integrators, well, you rely on these integrators for the rest of your life.
Right.
And they're needed, but they're not cheap. So again, it creates a have and have not. Those that can afford to pay that $400,000 to integrate well, those who can't.
Right.
And automation, used robots are not expensive. You can buy a used, welding robot for $5,000 or $10,000. Mm-hmm. And if you can read a book and have a little bit of scientific background, you can get that working yourself. But it's going to be a hard slog.
Right. So, what would an ideal world look like to you in terms of, employment versus, automation, or, whatever the melding of the two look like? And I guess that kind of also plays into the education system. Like, where do you think our education system should be focused right now?
So what I try to do with automation is I look at my pain points and my monotonous parts that are, which you don't want someone doing anyway, because they're going to turn off the brain 5 hours into doing the job and problems going to happen.
Right.
We do our own training in-house as well. So anyone that comes to me as a laborer gets the opportunity to step up to be a machine operator, fabricator, and a welder, and we will train. I don't want people pushing buttons and pulling levers. If I have someone that's intelligent and can run a machine that has to pull a lever and push a button at times because we get busy, then that's what I would like. I like people that can think on the feet, and that's one of the problems with AI is the thinking isn't there; it's a program.
Right.
So if you don't program it yourself, is it going to consider all of the issues that you would normally, see in your field, right? And having someone program another company, I don't think it happens. As far as training, I think some of the states are starting to do it now, where they're starting to train more fabricators, welders. But I think where they're missing the point is they're, again, trying to train one field at a time. UK used to have a system called EITB, Engineering Industry Broad Training. And what it was you got your hands wet in 4 or 5 disciplines. So one of the things I did was mechanical, electrical, I did some civil, we did some welding, we did fabrication. Because if you're a mechanical engineer and you're designing for someone to build a fab shop, there's no point designing something the fabricator can't get into weld, or he can't drill a hole because you haven't allowed the right spacing or the right material, whatever. And that's where I think we've gone wrong, and where we will continue to go wrong until we go back to broad-based training, where we actually have people trained in a wide facet of ability. If they want to specify later, or going through one route they can do, but I think the initial 2 years should be a broad-based training for industry.
That's an interesting perspective. I don't think I've heard anybody talk about that before. It makes a lot of sense, though, because it's the same encouragement I give to manufacturers. The more vertically integrated you can be, even if you're a CNC shop, having some welding and fabrication capabilities, or having a variety of different capabilities is going to make you a much more attractive company to a lot of these OEMs, because they're looking to consolidate supply chains. So I think what makes sense on a personal level there makes sense on a business level too. So with regards to Hollobus, how did you see this need? Well, describe the product, describe what it does, and then, how did you kind of get tuned into it?
So Hollobus is a rigid busway. That's what it's classified under. It's fully wet dry rated, which means it can be installed indoors, outdoors, on a roof, in a trunk. It can be flooded from time to time. And really what it is a really robust power feeder that has a lot less installation hours required to put it in. And the reason we came up with this is there are a number of ways of moving energy around the space, right? Or in buildings. Pipe wire, cable and tray, rigid bus duct, cable bus, and there's various other means and methods that get used every once in a while. The problem with a lot of the feeders that are have the most longevity, which means they're bulletproof, they take a lot of labor to put them in. So, for instance, pipe and wire, you have to, install the pipes, and you got to pull the cables through before you terminate. It's a massive amount of labor. Cable and tray, you've got a whole bunch of deratings, so you have to increase your cabling, and it's a lot of labor to put that in. Cable bus is the best option in that area. However, a lot of people opt for rigid bus duct. And the reason why they opt for rigid bus duct is the perception is that rigid bus duct goes in faster, which means it's less labor to feel. And if you've heard anything about labor in North America today, it's not good. The amount of data centers that are getting built, the amount of AI and those scientific centers are essentially draining the workforce. There are so many projects currently ongoing in the U.S. I think it'd be hard, outside of a couple areas, it'd be hard to find electricians, a unionized electrician to get to go to work because they're already being used on projects.
Right.
Hollobus was designed to create a product with all of the benefits of cable bus and all of the labor savings of, for instance, what people perceive as a rigid bus duct. So one of the issues with cable bus is it uses cables. And obviously, cable bus manufacturer typically buys his cables from someone else. So there's a markup and a markup. And then the cables themselves aren't as efficient as it could be because of issues with skin effect. And then magnetic fields inside the feeder that could cause all sorts of havoc. So Hollobus was designed to essentially get rid of cables, provide a robust feeder. Instead of using solid conductors with insulation jackets, we use a hollow pipe type style system with a jacket on top of it, so it's still insulated like a conductor. What this system allows us to do, I'm sorry, it's dry, but what this system allows us to do is get up to 25% further downstream with the same bolt drive. When you consider the same cross-sectional area of your conductor. It's also fully built in our factory now. So unlike cable bus, which is built in parts and pieces, then assembled on site by contractors, Hollobus is pre-built in the factory, and essentially it's just put in place and connected to the next piece. So the labor savings on Hollobus can be probably upwards of 60% or more in on-site labor.
Wow.
When you look at today's age where data centers are, putting in, they don't put in one feeder, they put in 75 feeders. And the amount of electricians that you need on site to do that, Hollobus is a product that will probably allow you to cut your workforce in half or less.
Holy cow. Wow.
And there is a slight increase in cost because we build it here, but the increase in cost for having a finished system delivered to you doesn't even come close to outweighing the savings that you'll see in the field with it.
Holy cow. Yeah, I mean, it sounds incredible, and I wish I understood a little. So, growing up, working for a general contractor with my dad, I've installed a couple, electrical panels in my day, and run wires. When it comes to the commercial scale stuff, I have no idea.
They are just giant extension cords. Some of them are permanent. Well, most of them are permanent, but some of them are temporary. But it's an extension cord. It's a big generator connected to a piece of gear. And instead of household current 15 amps, 120 volts, it's 4,000 amps, 40 volt three phase. So the feeders are 2 foot wide, 5 foot deep. Right. It's just scalability is all it is.
So you saw this problem in the space. You saw the labor-intensive operation, and just decided one day that you were going to design this?
Yeah, initially it was designed for that, and also building high-rise tenant rises.
Okay.
So one of the things we found in buildings across the U.S. is the tenant rises typically go at a two-way voltage, which is really low. If you've done electrical, you're probably familiar with volt drop, right? The longer you run it, the more voltage you drop, and you're only allowed so much by code. So in a lot of these high-rise buildings they built today, they have multiple feeders going up this building because of all the volt drop, so they can't do it in one feeder. So Hollobus was initially designed to do that job. So it can take 208, 4,000 amps from the basement of a building up 70 stories with one feeder and deliver it to the top within the specified volt drop. And then as we were designing that for that purpose, we looked at, well, hold on, we can make it longer, we can put it on thresholds, and we can save all this labor in the industrial side as well.
Fascinating. Holy cow. So is Hollobus the main focus of your manufacturing right now, or are you developing other products?
We do have a couple of products in the BESS battery energy storage solution system that we're working on right now.
Oh, okay.
They will probably be launched in about a year, I think a year and a half. So,
okay. Yeah, I mean, that's a perfect complement when you're talking about data centers.
Yes, and I think at some point people are going to start realizing that solar, if solar is done efficiently, it works. We are in the process of establishing a 3.5 megawatt solar field on our roof, on our factory, and we have a 6 or 7 megawatt battery solution, storage solution going inside our factory. And we did this for two reasons. One is to learn all about it ourselves. And I don't think as a company you can call yourself an expert until you've actually invested your own money and your own heartache into designing it and making sure it works.
Right.
And two, we did it this way is because solar is such an interesting product. It could be so cheap, right? A panel, a 560 watt panel is only $90. But most of the solar people sell it for $300 and then installation on top of that. So the cost of solar is through the roof, and there's no reason for it. It's just greed. That's only one thing. Your solar should give you an ROI of less than 5 years, right? These people that are talking about solar systems or battery energy storage solutions, taking 10, 15, or 20 years to pay themselves off. I don't think it's actually credible. If you can't pay it off within, I would say, 3 to 4 years, then it's not doable. The system that we're designing, you will be able to do that on large scale as well as small scale.
And so where are you innovating there? With the actual battery technology, or like how are you getting that, or what?
So we're not we don't manufacture the panels, we don't manufacture the batteries, we don't manufacture the gear, right? The gear is designed to our spec. So we work with a gear company right now designing a special piece of gear, and part of that is taking it island-based instead of grid-based. Because half the battle with solar today is people spent millions of dollars putting a solar field in because the utilities were giving them 19 cents a kilowatt hour, and then 4 years later it's down to 3 cents a kilowatt hour. Well, you can never pay your system off. So you're actually better off not supplying grid power. In my eyes, you're better off actually going an island and supplying the power for yourself. That's where you will truly save money right now in solar. And at some point, the grid providers will come back and talk to everyone that has an island, because the grids aren't big enough for what they need today. We're hearing all these problems about data centers and builds and towns that are starving for power. Well, there are easier ways to solve it than we're actually looking at today.
Yeah, that's a really interesting conversation. I mean, I've been fascinated with solar technology. And I've actually thought, I'm kind of a weird, like, off the grid sort of, like, this is my fantasy, not my reality. So I'm always looking for ways. Like, I installed a a wood burning stove in my fireplace, and I burn wood all winter and stuff, and I grow a garden. Like I'm a hunter. Like I'm very much like be in touch with the land, try to stay out of the system kind of guy. Here I am on a podcast. But so I've thought about solar a lot, but then I look at living in Erie, Pennsylvania. I can't remember what the number is, but we have comparatively very few sunny days per year. And then obviously in the wintertime, you're dealing with snow buildup on solar panels and things like that. And to me, it just didn't seem like it would work.
So it's not for everywhere. However, as long as it's daylight out and the sun comes through the clouds, which is usually, the panels will still produce. They may not produce to the full capacity, but they'll produce panel capacity.
Right.
And one of my design traits has been, throw the book out the window with how many panels I can put on this inverter. If panels are $90 a piece, right? And I need, let's say, 20 panels on a proper day to do it. Well, I can put on 30 or 40.
Right.
Or even 50, right? It's an extra $500 or $1,000 on the system, or a couple of thousand on the system. But now if half of them are covered in snow, or we have a really overcast day, it's still providing more than enough energy than I need, right?
Interesting.
The inverters today will clip off the excess energy and ground it, or take it to your batteries if you put batteries on it, which is what we do. Rather than, the inverters and all the electrical systems that they like charging money on, put more simple stuff on, just more panels. That's all you need.
Interesting.
Right.
Do you worry about, having to convert the electricity from DC to AC? From what my understanding, you don't get a true sinusoidal wave from that type of AC, and could be problematic to run equipment with it. Is that
so on the large? Yeah, no, it's fine. On small household systems, yes, I agree. But you can get DC water tanks, DC ovens. You can get a whole bunch of product now, so you actually don't need to go to AC on your own.
Okay.
Right. You could come straight off your solar field. DC inverters for air conditioners, DC ovens, DC everything is available in DC now.
Interesting.
So, and it's not expensive, right? It's not too costly for the average person to use.
So if people are paying these 300% overpriced prices for solar panels and the equipment, where should they be looking to get it?
Well, that's the question right now. Because the issue I have is the amount of companies that have been charging these money and still going bankrupt, and I can't see how they can. If you get $300 a solar panel that you're paying $80 for, and you're charging them to install it as well on top of it, how can you possibly go bankrupt? There should be enough money in there that, unless you've got a Learjet hidden somewhere and a couple of Rolls Royces, I don't see what the issue is with a lot of these solar companies. Tariffs don't help, right? So obviously, the playing and the moving of tariffs around North America currently is a massive investment in anything, especially manufacturing. I have no idea what a product's going to cost half the time because I don't know what tariff's going to get levied against, any type of company or copper or aluminum or steel by the regime in power. So it becomes difficult to find people. But one of the things that we're going to do is when we get there is actually put out a database of people that we have talked to and have vetted to make sure that they are not going to rip people off.
Okay. Yeah, that's cool. Very helpful. Well, I guess I'll give solar a second look because that is really interesting to me. The tariffs. I talked to a lot of manufacturers, obviously, and even going through the trade show. We talked with a lot of companies, just asked some questions, and everybody kind of seems on the same page. Like everyone seems to understand the need for tariffs in some cases, but it's changing too much. There's too much uncertainty. Like we need to know like it's going to stay this way, so people can adjust their business models to reflect that. But when it changes every other week, it's very frustrating.
It doesn't work. So if you want to attract business, give them tax breaks. Come here, print jobs. We'll give you and a real tax break, not some little carrot hanging off a stick, right?
Right.
But the money has to stay in the business, right? So I would even allow a large business, as long as it's keeping its money reinvesting in its equipment and in its workforce, I would say, you know what, tax-free holiday.
Yeah.
So the minute that dollar leaves that business to a director, a shareholder, something like that, you tax the living crap out of it, right? But tariffs don't help anyone. The consumer pays the tariffs always.
Right.
It is a tax. And what happens is the consumer buys less. So when you put tariffs on anything coming into a country, what you're actually doing is creating a shrinking marketplace. I am the poster child for the Trump campaign when you think about it, right? I am a Canadian businessman who came down to the U.S. With an investment to create a factory in the U.S. and a factory in Kentucky, Hollobus, right? So I'm his poster child. You know, we're bringing business back to America. Well, I wasn't even in America, but I'm coming to America to do business. And then you shot me in the foot with your tariffs because of the fact that my equipment's cost me twice as much to get, because we don't build anything in the U.S. right now. And it's easy to say the tariff and enforce us, but it'll take 3, 5, 8, 10, or 20 years to build up our industry to the point where we can get a lot of the products in the USA. So right now you can't, so you have no choice but to bring them into other countries, but you're paying a massive tax to do that. You know, for the joy of providing jobs and stability to the American people, which is asinine to me as far as from a business look, right? It doesn't make any sense whatsoever.
Right.
You know, let's be honest, you tell IBM or one of those big three, if you come back to the States, do you manufacture in the States with zero taxation on your corporate, they'll be here tomorrow. Right? You know, the automotive manufacturers will move between Canada and the US. If the Canadian dollar gets too strong, they'll close the factory, move it to the States over a few cents. Or if the taxes change, they'll move it. They'll move the factories across for a few cents. So I don't know why the route for tariffs were actually taken, because they don't work for anyone. And if anything, they're actually causing a disservice to the American companies.
That seems to be the general the general consensus. Yeah, because it was the stated intent that it was going to bring manufacturing back to the U.S. But yeah, obviously, if everyone's being hurt by it, because no manufacturer lives in a bubble, they're getting services, product, etc., from overseas. You know, either firsthand, secondhand, or thirdhand, and it seems to be hurting people. So yeah, I don't know. There's enough people uncomfortable with it and streaming about it that you would certainly think the word would get to the top. So I guess we'll see what happens. I don't know. But as entrepreneurs, this is what we deal with. We, like you said before, we spend all this time and effort building businesses and doing the best we can, and it feels like the government doesn't even want us here.
Agreed. Yeah. That is the federal. I have to be. One of the things I have noticed though is the difference. So having a business in Canada, where you're right, I don't think the government wants you there. They just want hotels and environmental stuff there. Coming down to Callaway County in the U.S. in southwestern Kentucky, I have experienced a very different dialogue from the local the government officials. And really why I'm here. They have helped me in any way they can. They're not here to put walls up against myself, or the company doing things. It's any way they can help us to grow and to create a viable factory, they're there to do. The difference seems to be the difference between statewide and federal, I guess. Because I don't know what the tariffs are doing. To me, they're a slush fund, but we'll see how that shakes out. Because here's one of the problems which no one's talking about, right? Is we have a SUMTA, right? And we have NAFTA. There's many names between Canada, Mexico, and USA. So you have companies in Canada that buy product on the worldwide market for the standard worldwide price, because it's pretty stable out there, right? So there is really no massive drop or hike. So they buy them for a reasonable price, and they put them together in the product, and they ship it across the border into the U.S. as part of NAFTA without tariffs. Same company building a similar type product in the U.S. has to bring his materials in from other companies, pay the tariff on the materials, because it's chances can have aluminum, copper, or steel in it, right? So he's got to pay an elevated rate for those. He's already behind the eight ball, and he's just starting to manufacture. So not only is he going to find his marketplace in the States being harder, it's going to be almost impossible to sell that anywhere else in the world.
Right. No, that makes a lot of sense.
And that's what I don't understand as a manufacturer. It's like, why are you doing this? You're taking our legs out from underneath us, right?
Right. So. Yeah, I hope, I've looked at the fact that, obviously a lot of these European countries, you can't even sell a U.S. car in Europe because they have 100% tariffs on it. I hope that this was like, okay, guys, you got to cut that out. You got to let our cars in. Until then, we're gonna tariff you. Yeah. But obviously it has to clear up at some point. But yeah, lots of challenges in the world, but it sounds like you're making a great go of it, and you've had a lot of success with the Hollobus and a lot of the other products that you've manufactured. Obviously, a very smart guy and successful, and I think a good model for a lot of the manufacturers that might be listening to to look at and emulate some of what you're doing.
And if there's anything I can say to manufacturers out there, and again, I'm not talking to the the publicly owned ones. I'm talking about the family guys. Is if you count your dollars and do it smartly, you can automate. You can compete, right? There seems to be a lot out there that's starting to close just saying we're not going to do it. You can compete. There is a way. It's through technology. It's through doing things a little more flat than a large business would do, right? So you can save costs that way.
Right. Yeah, that's good advice. What would you say the first thing they need to do to go down that path is?
Well, if they have a whole bunch of middle management, get rid of that first, or at least make sure it's competent in what it does. And two is, if you know your product and you know how to build it, you know the equipment you need to make it for you. So don't take equipment that's being handed to you as available. Make sure it's designed the way that you want it. And my advice is hire a couple of mechatronic engineers. I think all manufacturing companies should start taking university graduates, to start actually doing co-op programs for these university graduates, and then putting these kids that have some fantastic ideas. They come in usually 3 to 6 month stints, right? Because it's part of getting the degree in engineering. Bring them in and put them on projects. Create projects for them. Create ways for them to design new ways for you to build stuff, or look at the stuff that you're building now and figure out a better product. The old adage, we've been building it this way since 1965, is done, right?
Right.
Innovate or die.
Yep. Yeah, and getting that fresh set of eyes on it too. Like we were talking about before, when you won that bid, it was because you had very little experience in that specific use case, and that was what allowed you to innovate. So having these fresh college graduates or about to graduate, take a look at some of your processes and apply some of their youthful creativity. That makes a lot of sense.
Yeah. It helps in two ways. It helps train our engineers better because they've actually got proper hands-on training, not just working with some large conglomerate where they're going to analyze a screw for 12 months, right? They actually get a chance to think outside the box, to design, to develop, and to work with a team. It's going to make them better engineers, and it's going to make our workforce and our manufacturing in general over the next 10, 20 years much better, because we're going to have a wider range of abilities in the youngsters that we train up to actually take over. Because I'm close to retirement age. I've retired 2 or 3 times already, right? Someone's got to take over at some point. Right. And unless we start to train them train the gifted ones and the ones that want to learn, then we're not going to have anyone to take over.
That's right. Yep. Well, thanks a lot for coming on today, Martin. Really appreciated it, and very impressed by your track record, and look forward to chatting some more in the future.
Thank you for having me, Nate.